Okay, back here with a example of, as you can see, performing simple linear regression. I You probably have done this numerous times, in particular in high school course, may have been a pre-calc or an algebra course. These types of threads are often, interjected, particularly in algebra when you're talking about lines and slopes and so forth. But what I wanted to do is just there's a couple little nuances that ALEKS does in here that kind of force you into using some features of ALEKS. So I wanted to be sure that I address those because it could be a little frustrating. Typically, again, when you would have a given data set like this, where we have our X and Y values, so to speak here. The data file size is the X and the completion time is Y. Typically, you'd enter these into some sort of software. For instance, if I come over here and show you, if we have our explanatory variable here, X, and, I can name it whatever I want, and I would have typed this 67.2 and so forth. Let me slide this over just a little bit so we see it here. But if I put all these X values in here and all the Y values in here, um, then all you would need to do is just begin this analysis. So I got some extra ones in here. I didn't want to type all those in. And I'll tell you why, because it would, you'd have to hand type them in. There's no way, ALEKS doesn't let you copy any of the text here. I'm trying to highlight it, won't even let you highlight it. So they kind of force you to use this method where we're sending that information to a calculator, and then they'll crank it out in the formula, which is done internally in a software like this or a graphic calculator. It also, this further analysis, these are things that I addressed in the big idea video in terms of producing a scatter plot that does automatically for you residual plots. It takes does a dot plot of the residuals, and it also, does the inference here, and it'll do a t-test for the slope, which I again address in the big idea video. It also does prediction and confidence intervals very easily, as well as a interval, confidence interval for the slope or beta. These would be the intervals that I address in the big idea video with, using the equation to predict, an individual response or a mean response for a given value of X. So I just want to show you this software is kind of typical of what's out there. And this is, again, for being free, it's very useful. But ALEKS is going to force you to do the following. So I already hit the solve button here, so you won't have to painfully watch me type these numbers in. It'll just make the video longer. But what I want to do is show you where they come from. We do have 9 data points, so you could just enter that in by hand. But as far as this 123 and so forth, I don't know if you've used this feature yet, but we can send this data or these data to a calculator. So for instance, I'm sending the X's over now, and then to calculate the mean, all I have to do is hit the mean button and hit equals. I think there was something else in there. Let me try that again. Hit the mean button and hit equals, and there's your 123.33. I would do the same for all of these. I'll just pick another one here. If I want the standard deviation of Y's, just got to clear this out first. I'll send the Y data, then I'll just hit the standard deviation button. I know there's an X there and you're looking for Y, but this will calculate the standard deviation of whatever numbers are in there. So I'm going to go ahead and do that and hit equals. And there's your 112.068. And again, be careful to follow these directions also, because you are to round these to 3 decimal places. And if you're off by one number there, it's gonna throw the whole solution off. All right. The big one here too, again, maybe a little bit of confusing. All we want to do is sum up these X, Y. So they give you all these values. So if I do send those and I just hit the sum button, and then the equals, there's the 252, 649.8. Now, when I hit compute, what it's going to do is it's going to use these values, and this is all done internally on this other software, but this is kind of breaking it down step by step. It's going to give you the values for R and also the slope and y-intercept of the regression line. And then you have to hand type those in here. And I believe, again, they want these rounded to, let me just get out of here, 3 decimal places. And I think you can see they're giving them to you to 2 decimal places. So that's all you would type in there. The next thing you would have to do is graph. They provide the scatter plot, but this line you're going to have to graph. And you'll do that again. If you read the directions, again, it just says round the plot 2 points. So you're going to have to plot the point by using this. And what you'll do is you put in any x you want into this equation, you substitute an x and you'll type that value in here. So for instance, if I wanted 25, I would put it in there, and then I would put the 25 in for x, or you would need to put the 25 in for x and simplify this expression. And again, make sure you round it to 3 decimal places and type that number in there and plot the point. When you do that for 2 points, then you can just use this line to connect those, and it'll be done for you. And then lastly, again, for the predicted time here, they're just giving you a x that they want to make a prediction for. And you would, again, go back and substitute the 151.8 into the regression equation and type that in there. So it's conceptually, it's pretty simple, but like I said, it's just, there's a few little nuances that ALEKS is forcing you to do. And so, of course, you've got to, I guess, go along with the program there in terms of producing those solutions. So in order to get a good score on this type of question. Okay, so that's it for the simple regression. A lot of these other ones here, again, are for the most part self-explanatory. I'll be back again with one of the more in-depth problems when you're looking at the statistical inference. Okay, we'll see you then.